So, let's work through this geometry problem carefully and see how we can find the radius of the circle. We have a square containing a circle, and the circle touches all four sides of the square. So the circle is tangent to the square on the left, right, top, and bottom. Near the lower right corner, there's a small rectangular region. Its horizontal length is 4 units, and its vertical height is 7 units. The question is, can we determine the radius of the circle from just this information? Yes, we can. The key is to create a right triangle and then use the Pythagorean theorem. Let's call the center of the circle O, and let the radius be R. Now, draw a segment from the center O to the lower right corner because that corner lies on the circle. The distance from O to that corner is exactly the radius. So this entire segment has length R. Now, we want to break this segment into horizontal and vertical pieces so that we can form a right triangle. From the center of the circle, imagine drawing a horizontal line toward the right side of the square. Since the circle touches the right side, the distance from the center to that side is the radius. So the total horizontal distance is R. But remember, the small rectangle occupies 4 units of that horizontal distance. Therefore, the remaining horizontal portion is R minus 4. Now let's do the same thing vertically. The distance from the center of the circle down to the bottom side of the square is also R, because that is another radius. The small rectangle has a vertical height of 7 units. So the remaining vertical portion is R minus 7. And now, notice what we have created. We have a right triangle with one leg equal to R minus 4, another leg equal to R minus 7, and the hypotenuse equal to R. This is exactly the situation where the Pythagorean theorem applies. Remember, the Pythagorean theorem says that for a right triangle, the square of one leg plus the square of the other leg equals the square of the hypotenuse. So we can write R minus 4 whole squared plus R minus 7 whole squared equals R squared. Now, let's expand these carefully. When we expand R minus 4 whole squared, we get R squared minus 8R plus 16. And when we expand R minus 7 whole squared, we get R squared minus 14R plus 49. Therefore, our equation becomes R squared minus 8R plus 16 plus R squared minus 14R plus 49 equals R squared. Now combine the like terms. We have two R squared terms, and negative 8R minus 14R gives us negative 22R. Also, 16 plus 49 gives us 65, so we get 2R squared minus 22 plus 65 equals R squared. Now subtract R squared from both sides. This leaves us with R squared minus 22R plus 65 equals 0. At this point, we have a quadratic equation. It doesn't factor nicely using simple integers, so completing the square is a convenient way to continue. First, move the constant 65 to the other side. That gives us R squared minus 22 equals negative 65. Now look at the coefficient of R, which is negative 22. Take half of negative 22, giving us negative 11, and then square it. Negative 11 squared is 121. Because we add 121 to one side, we must also add 121 to the other side to keep the equation balanced. So we have R squared minus 22R plus 121 equals negative 65 plus 121. The right side simplifies to 56. On the left, r squared minus 22r plus 121 forms a perfect square, so we can write the entire left side as r minus 11 whole squared. Therefore, we have r minus 11 whole squared equals 56. Now take the square root of both sides. Remember, when we take the square root of a squared quantity, we have to consider both the positive and negative possibilities. So, r minus 11 equals plus or minus the square root of 56. We can simplify the square root of 56 because 56 is 4 multiplied by 14. The square root of 4 is 2, so square root of 56 becomes 2 multiplied by the square root of 14. Therefore, r minus 11 equals plus or minus 2 square root of 14. Now add 11 to both sides and we get r equals 11 plus or minus 2 square root of 14. So, algebraically, we have two possible answers. R equals 11 plus 2 square root of 14, or R equals 11 minus 2 square root of 14. But here's where we have to be careful. In geometry, we cannot simply accept every algebraic solution. We have to check whether the answer actually makes sense in the original diagram. Remember, the two legs of our right triangle are r minus 4 and r minus 7. Since these represent actual lengths, they must be positive. In particular, r must be greater than 7. Let's check the smaller solution. We have 11 minus 2 square root of 14. Numerically, that is approximately 3.52. But 3.52 is less than 7. That means r minus 7 would be negative, which is impossible for the length of a segment in our diagram. So, we reject that smaller root. That leaves us with the valid solution. R equals 11 plus 2 square root of 14. If we calculate this numerically, the radius is approximately 18.48 units. So the final answer is approximately 18.48 units. And notice the important idea here. Solving the quadratic gave us two algebraic possibilities, but the geometry itself told us which one was physically meaningful. If this step helped you understand how the Pythagorean theorem and completing the square work together, make sure to like the video, subscribe for more geometry problems, and comment your answer below before moving on to the next one.